Good morning, goons and mutants. What's wrong with this picture? What's wrong with it? Well, I'm tempted to say nothing. I'm tempted to say, why not? Why would you not? Here's that 72 placed inside of a much nicer cabinet. Now, whether or not you like the aesthetic, that's up for debate. But this is an amp that's going to be played, obviously. Let's just take a walk down Tube Alley here. Look at that guy. Is that on the envelope or is that inside? Oh no, let's see if I can clean that off. But at any rate, oh, look at that. Look at that. Look at that. That is not an original output transformer. Let's see what's up. Let me get this thing opened up. All right, first things first, and it's not the coffee. Let's get her warming up on this current limited circuit. Let's crank her up to 80 volts. And I'm hearing a little tap, tap, tap on the inside of these glass envelopes. Look, that guy doesn't even have any discernible filament action. All right, what's our light bulb telling us? Let's get this light off. All right, let me take her up. Now, granted, this is in standby. Let's take her out of standby and observe this tube. Can we focus? It's one of those days when you hate your phone, isn't it? We're going for it. We have one tube conducting and one tube not. Well, it's terribly microphonic even as it is. Barely any action there from the lamp. Let's get her turned up to 110. I could hear the filaments being disturbed as I juice her up. We have a little activity there. Bring her up to 115. So take a listen. If you can hear, get the microphone right in there. What I can hear, and you may not, is a slight rattling sound as the current is going through the filament. It's disturbing it. Could be warming up and expanding. In any case, that tube is obviously shot. It's not getting any sort of filament current through. Maybe it was shorted at some point. And this hum, making assumptions obviously, it is due to more than the lack of having that second tube in a push-pull pair doing a common mode rejection trick. So let's get her turned off and remove her from the cab. You always want to look before you grab things. Wow. I could have literally electrocuted myself. I could have killed myself. Thank goodness. Thank goodness I looked. All right, let's see what we're dealing with. I can't discern the brand at the moment. Oh, look at that. But I do know this. I'm gonna have to remount this. If I drive anything in through here, it's gonna go through the circuit board, but I can actually move the whole shebang over just a touch and remount it properly. This is becoming more interesting. All right, Ezra, your bias is topping out a little on the cooler side. I'm gonna adjust the range resistor, so about halfway up the pot's rotation will get you right in the sweet spot. Check this out, listen to this. Hear that? So I'm gonna clean this out, but in the meantime, let's see if, watch this. In the meantime, sorry about that. Let's see the influence of this thing's position on the output hum. Okay. Okay, relatively quiet right now. It's making no discernible difference, so I have a little bit of flexibility as to where we mount this. In other applications, the way you orient the transformer with respect to electromagnetic radiation being induced into the output, and in other instances, where you place the laminations with respect to the other transformer, it's incredibly important. But again, in this instance, it's not. So we have a little bit of wiggle room, which is nice. And you can see that this thing's been mounted quite a few times. It's starting to look like a colander. Like I can make pasta and then drain it on this thing. So let me find the best spot to mount this output transformer. And these new output tubes are right now, from a noise perspective, nice and quiet. These caps, while not the best, they're great. They're in great shape. I'm gonna take a look at this and make sure we don't have any issues. It looks like this wire right there was really close to that eyelet, and when the dude was soldering, it started melting that jacket. So we'll make sure that the conductor is still insulated, so that it's not gonna essentially short to the leg of this filter node, which is your phase inverter supply. So talk to you soon. Whoa, look at this. Look at this. Fender Deluxe Reverb. Top of mind with this impedance, with the primary impedance, you're only able to run 6V6s and EL84s on a transformer with these specs, and not 6L6s, certainly. So I like the idea of a lower output transformer for lower headroom and increased compression, something you could really accomplish with upsizing the screen grid resistors. But here's another way to do it. It just looks like a battlefield repair. Ooh, I don't know. Let me dig into this. I have a tool that will come in next week that will help me validate inductors and such, and then I can get I can get like winding ratios or turns ratios and the whole thing. That would be nice to have now, but let me see if I can get the meter on this thing and figure it out. All right, I thought this is super interesting. What's not interesting, this is a terrible job. Look at that, just tack sawed it on. I gotta redo this. But look at this. January 27th, 1972 by Richard Hand.
You done made me hurt my dick hand.
Over at the Fender factory. I've never seen the technician's name up there without it being a code. It's pretty crazy. Usually it'll be like, you'll see like a service stamp on the back of the chassis that indicates it was brought back to the factory for service, repair, etc. You'll see like RC, which is the initials of the tech, and then 4266, which would be the 42nd week of, say, 1966. But I've never seen a stamp. Oh, Mr. Dick Hand. I like it. All right, so instead of burning up your potentiometer and playing guesswork with your bias adjustment, with this range resistor, let me grab a chopstick. Instead of playing grab ass, just lift the lead here, just swing it over, use this to connect, use the other side to connect the other lead for your decade box. So in an ideal situation, you'll have, 70% max plate dissipation, and I just got finished. Let's see where the middle is. Right there, about right there. You'll have your sweet spot right in the center of the pot's rotation. So let's see what range resistor needs to go. I'm gonna start this off with 20 kilo ohms of resistance. Let's get her plugged in. I wasn't going to show you guys this. Okay, and she is currently current limited. Let's get her turned back on. I don't know, for whatever reason this guy's not. Oh, we got a bad connection in the socket, so I need to tighten up those, obviously. Let's see where that's going to put us. Okay, you have permission to warm up. There we go. And you can see the inverse relationship between plate current and voltage. Okay. So obviously this is not where it's going to go. 20K is a little too much. Let's try 10K. I'm looking for like 45 milliamps of plate current. Okay, let's do 5. Actually, I'm fine with 5. I'm fine with about 5K resistance, and I could swing the pot over. So 5 or 6K. And what you'll find is if you're moving from a vintage or a new old stock set of power tubes onto a more contemporary set of output tubes, what you'll find is that they're colder. And you're going to run out of range on that pot really quick. So just expect this to happen. So let's get her set up with the right resistance. All right, so don't pay attention to that 60 hertz hum in the background. We have a dangling power transformer in essence. And we have a tube that's making poor contact at the socket. I'm going to take care of that. That's going to stabilize. I do have a 1 milliamp wiggle. That's not a big deal. I like it. And we went with a 6.8K. That's the pot cleaned up. I'm going to go ahead and evaporate the rest of that isopropyl alcohol and clean that little trimming down there. And we'll see you in a minute. All right, we got a new bear trap for your rectifier tube there. Keep her secure. You know what I just noticed? Oh boy. Let's see if I can get this tightened up. All right, I'm just wrapping up the retention of the power tube sockets after deoxidizing them. Here's a tip. If you find that, and this is what I use, very fine jeweler's screwdriver, and sometimes this tool. If you find that you've run out of space for your tool to be inserted, you can put that guy in there and then torque them over. You can see it. Let me zoom in. Boop. There's going to be space already because I just retensioned all these. But you'll insert that there and you'll just pull it over. You see? Now there's space for you to insert your tool and then gently press into the tool, and you'll have a nice retention socket there. Just work your way around. Don't go too far, or you could, God knows, I mean, this is from 1972. That makes it like 47 years old, 46. I don't know. I'm not doing math this morning. So, think how many times this has been retensioned. Maybe not at all, but who knows. So, that's just a little something for you. Oh yeah, and another thing. So the reverb is not functional. Well, you know that, Ezra. It's not functional on this amp presently. Boop. Nice. It's not. Stop trying to look at me. You guys may or may not ever see my face, and that'll be a good thing. No one wants to see my tired and melty face. So just working my way down these sockets. These are all microphonic in some way. I'm assuming that, I mean, we do have some Ruby tubes from the 90s here. We do have some tubes from the 70s in 3 or 4 positions. But check out this 12AX7 on the reverb recovery side. Look at these nasty pins. We've all seen this before. But did you know that the best way to straighten them out is if you ever buy a new old stock tube and it comes with one of these guys. And what is this? This is just something that protects the tube while it's in transit. Well, guess what you can do? You can see a small side, the diameter that is, and then there's a larger side. Here's what you do. To rough in the shape, you just insert the tube, there you go. Get that nice and crisp for you. Then just give it a little turn because I can see the direction this is going in. Carefully pop that off. And then what you'll do is through the smaller side. I'm trying to do this through the camera. Pretty difficult. There we go. Through the camera, you'll do the same thing. And at least it'll line the pins up. Now I could see that there's still some deflection there. And that's just the way it's going to be. But at least you know it's going to line up with your socket. Here's one of the original 70s RCAs. You can just barely see some of that silk screening on your driver, the reverb driver. Just barely there. You can see that. I get a hint of that orange-red kind of RCA silk screening. Still there. So let me move the chassis stand over gently. And maybe this is one of the reasons why I haven't done any voltage checks on the preamp. I just stood up the power amp, so let's not put the cart ahead of the horse. Let's get this over and see if I could swing her around. And, okay. So what I want you to focus on, ooh, a little crispy, huh? Get that light going. Now this, there we go. This thing does have a function where that's carbonara. This does have a function where I should probably try to lower this so it's a little more clear for you guys. But you know, I'm doing my best here. Give me a break. There we go. That's heavily oxidized, right? So let's count them up. Now, clockwise orientation, you would have pin 1, 2, 3, 4, or so on. Now, that's not the way it is because we're looking at the opposite side. So this would be pin 9, which would be one of your filament pins. Pin 8, that's a cathode. Pin 7, that's one of the grids. And so on and so forth. There you have it. We need to clean this guy out, potentially. So we have 9, 8, 7, 6. We have a plate connection here that could be dodgy. 4 and 5 will be your filaments. We have another cathode there, another grid there. And then we have your plate on the other side, on the A side of the tube. Let's get that cleaned out. And that's why we deoxidize these things. This is responsible for a great deal of the noise you guys typically observe in these old amps. Then you send them to us, but this is something that you can kind of do yourself. And I'm reticent to give you any more information because you can kill yourself. Say you're touching the chassis with one hand, and then the other one you have your conductive tool, and then you hit the plate. Well, it's going to cross right across the old chest cavity through your heart and potentially kill you. So that's why we don't really give you guys advice like that. This is not a DIY channel. This is just something where I talk to my clients, and now I'm talking to you, I guess. I'm talking to myself. Let's see if I can clean up that plate pin and I'll get a good angle in there. There we go. So that looks better. And if we're not getting the electrons boiling off of that cathode on this side, then we're not getting conduction. So these all look well tensioned. What I'll do is I'll put a little bit of contact cleaner. I use QD electronics cleaner, or electronic cleaner. It's safe for sensitive electronics, they would say. And it is. I mean, it dries without leaving a residue behind. And then what I'll do is, and beforehand, I already kind of brushed the pins off here. You can see how nasty some of these are. That's poor contact. Certainly, it's going to offer some resistance or impedance. And it'll kind of play into the Miller capacitance of the tube itself. So this will change things if there's any sort of oxidation there. Let's give her another brush. Brush her off. What are we doing? Nothing good. I've moved everything over. So we'll brush her off and continue working on this socket here. And I've got this, where are we at? Boop, secured. All right, Ezra. That's such a cool name, by the way, dude. I never told you. Let me get a chopstick. And I am getting over a cold. Boop. That's an old GE right there. Look at that guy. Unfortunately. Now let me draw the volume down on the second channel. Already the background hum has been significantly reduced, by the way. All right, full volume. All the tone controls are up on this channel. But listen, I'm going to take these two out of the equation. Listen. That's just that guy. Okay? This tube is roasted. It's not roasted, it's just mechanically noisy. Some might say it's lively. Now, let's head on over to your effects channel. Turn her up. Take these out of the equation because I think I have your reverb level up. Yeah. And I'm still not getting a corresponding increase in background noise when I'm turning the level all the way up, so that's concerning. Maybe we have a dead tube. I'm not certain. Listen. Very loud. Now, let's get the reverb level up and see if we could at least get some microphonics out of it. I did notice that jiggling the tube caused some static noise, so that's a good sign. Let's make sure it's not this guy. So your 12AX7 12AX7 here, or AT7, I'm so sorry. Your 12AT7 here, whoop, right here, sorry guys. Your 12AT7 here She's not too healthy. Let's look at replacing her. But before I do that and venture wildly into the land of assumption and probability, I mean, as you can hear, the recovery tube is working from getting the old crispiness. You hear that? So check that out. We have no more hiss in the background, but now we do. So what does that tell you? Well, it doesn't tell you much. It does tell you that the signal, the clean channel, rather the effects channel signal is mixed back into that tube. That's what that tells you. So that's not saying anything about the particular health of that tube or the circuit. It's just telling you that that signal is being mixed back in and is being transmitted through the tube over to the phase inverter. But we have more probing to do. So I'm going to yank these tubes here. Which tubes? Sorry about that. I'm going to yank these guys, and let me get some power levels, and then I'll show you guys what I'm finding there in the meter. But yeah, it's just to go back to an earlier point that I made in the beginning of the video, and that noise is just the RF coming off of the phone. If you're changing tubes, don't reach back here. You need to get a doghouse cover. You could kill yourself. Make sure if you're going to be changing tubes that this thing's been powered down overnight, just to be safe. But get a doghouse cover. It's something you could put on yourself. It's just 4 machine screws. No big deal. All right, let's get her set up. The old Agilent. All right. Let's get her ready to roll. There we go. So that's what we'll do for you. Let me get my ground connection set up. Really quick. And then sometimes I don't know if I told you guys this, but I'll use a red lead for a ground connection oftentimes, because I'm going to obviously keep the positive in my hand. I'm not going to conflate the two. And why do I do that? Well, very simply because I see it. It becomes dreadfully obvious. There she is. Boop, right there. That it's still plugged in, isn't it? Yes, it is. So let's probe around this socket. We're nice and juicy. We still have power. Get these spare tubes put up, and let's see what kind of readings we're getting. Let's start with the. Let me bring my probe lead underneath. Don't shock yourself. Don't shock yourself. There we go. Just so I could give you guys a relatively unobscured shot without all these leads dangling all over. So let's start over. Let's get our filament supply. We'll go to volts AC, pin 9. You can see we're getting 2.9. That's nice. Then we'll do a 1, 2, 3, 4, and 5. Looking good. And since I'm there, I'll just switch hands for you. We got that guy. Good to go there. And good to go there. So we can get into DC. All right. So obviously over here on pin 8, you're not going to get anything at all because you're not conducting. So there's nothing to see at the cathode at present. We'll flip her over and see if we're getting a requisite, sub 2 volt range reading. So we shouldn't see anything on the grid there. Maybe just a touch. Hopefully we don't have any leaky caps, but it looks like we've had a cap job done. All right, and then we have our plate running at 397. That's okay. I expect to see that elevated because, again, we're not conducting. And again, this is pin 3. We're not going to see anything there. Pin 2, shouldn't really see much of anything there. And then our next plate, 397. So that's good. So let's go pin 1 over here. I'm so sorry, this is pin 9. 8, we're not going to see anything as a cathode. 7, shouldn't see anything. 6, there's our plate, 357. Let's jump over to our next plate. We're at 357. And then everything else looks good. So what do we know? Well, we know that at least we're getting power from the little guy here. It's not telling us much else. Let's see if we can get a different pair of tubes in here, because these guys are a little juicy. Rather the driver, not the recovery tube. The recovery tube we just replaced. So let's get a nice strong 12AT7 here from the bin. Okay. Let's see what we can see. Hear what we can hear. I don't know, taking you guys along for the ride on this. If this wasn't in a combo cab, I would say just leave these guys in there, or just leave your unused channel down. This could still be a very nice sounding tube, even though it's mechanically noisy. All right. There we go. Nice, here we go. So we had a failed driver and recovery tube. And I'm getting very little noise. Let's hook up the test tank. This tank has an impedance mismatch. Let me roll back, but it doesn't matter for our intents and purposes. This is meant for something driven by a chip. All right, but guess what? As far as we're concerned, we can still check it out. And this may bode well for you, Ezra. Because let's pray that your original tank is good. That's what we're going to do. And I'll get her flipped over and we'll take some other measurements. Let me take this guy off. It's just flashing over there. And oh, look at this little, we got a little crude shorting plug for your vibrato. I actually make and sell these. I'm not going to pump what I do here. But I'm going to give you one of mine. And you can get this back also, but here's what I do. Just do it a little bit of a different way. Just the way I do it. Everybody has their own little way of doing it. But this is it's a little trashy. With all due respect to the original tech, whoever did that. I don't like the little splash of color there. Slap my butt and call me Nancy. So let's get her put on standby so we don't have to hear any snap, crackles, or pops. Okay, and we're gonna clean all these jacks. I'm getting ahead of myself here because sometimes it's okay to flow. I have a certain order that I typically go through when I have an amp where the power amp needs to be stabilized. The order that I typically go in, it doesn't always work out that way, but sometimes, you know what? Part of the reason why I work for myself is so I can do what I like. There we go. Nice. Probably hear that. Beautiful. Nice. All right, dude, I'm happy with that. So let's get her flipped over. Let me check out the vibrato. I could check it out now. Might as well, huh? We don't need to break this up into chapters or verses. Let's just get a little bit of background hiss in there. I'm not running a signal through it yet. There we go. It's not responsive, so the cathode bypass cap on the oscillator circuit is a little oversized, so watch how long it takes to charge. So you're going to get a delay between the time you turn the knob and your perception of the effect. Listen. Turning. There we go. It takes like 3 seconds. You'll hear nothing in the background, and then all of a sudden you'll hear it kick in. Watch. Okay, here we go again. 1, 2, 3. 2.5 seconds. Let's do Mississippi's. 1 Mississippi, 2 Mississippi, 2.5 Mississippis. Mississippi's a great place, especially Forest County. For all you mutants and rednecks out there. I can say that. I have immunity. I'm from Louisiana. That's all right. Let me get her flipped over. Ezra. I'm doing a hardware check, so I'm going to obviously remove the knobs here. I'll clean all that stuff up. I like that little reissue faceplate, dude. That's sharp. I might see if I could realign it. It's a little off. This side needs to be... Where's my damn finger? This side needs to be brought up a little bit. I'll see if I can do that for you. If it hasn't been glued. Kind of feels like it's been glued on now. I'll see what I can do. But let's get that cleaned up, tightened up. And then when I was over here, I noticed this guy is missing a little bit of hardware right there. I do have some spare hardware trays here. I'm going to try to find a little something. It's going to fit in there and look nice, not too out of place. Let's see, this guy looks about right. If not a little, this guy looks about right. Huh? A little too big. But I think that's the right thread pitch and diameter. Here's the guy, the other one. I think it's a little small. Let me test fit it. If this dude, where's he at? If this guy ends up being the one, then I'll probably scuff him up so he doesn't stand out so much. Let's just see if I could reel this thing back in, this switch. All right, well, that's the one. That's going to be the one. All right, awesome. So let me see if I can get her scuffed up so she doesn't stand out so much. Or I might have a proper old one. Anyway, I'll take a look. This is neither here nor there, nor anywhere. I'll update soon. All right, got that faceplate cleaned up and tightened up. You know it's not a 70s amp if you don't have a little bit of that funky nicotine left on the markers. Look how nice he's cleaned up, though. I left a little bit of funk there. You don't want them so pristine. You want that patina. But you don't want to have that old sticky nicotine when you're actually interfacing with any part of your amp. It just kind of cheapens the feel, makes it feel kind of gross. So let's get these guys put back on there. Beautiful. These are all fully adjusted, fully aligned. Loving it. Let me see if I can get this hardware to match up a little better. Yeah, I like that a lot better, actually. So much more balanced, I think. Now check out what I was able to do in the normal channels. Look at that. Nice. This is as good as I can get the camera to go, but yeah, I had to take a look. Very nice. I'll get these jacks sorted out as well. See what I can do. Again, we're going to maintain some patina, but just get a little of the funk off. Yeah. What do you say? The other side there. Just zoom in. Nice, huh? All right. Let's do a little tweaking on the actual tone itself and see if we can optimize. I'll get back to you. All right. Here's where we are currently having an issue we're going to have to work through. Listen. You hear that? See if you could hear it. And if we have a little bit of a parasitic oscillation in there, the wiring does look pretty messy. All right, so getting down into the nitty-gritty. We got some really rotten solder joints throughout. Some of them are starved, some of them are cracked, some of them are just nearly non-existent. So I'm going to go through and correct these. Look at this guy. Look at that, dude just went ape shit. Good Lord, man. So the jacks for certain need to be cleaned out. I'll get in there between the switches and the contacts, knock those guys out. The distortion that I heard on the pick attack and the decay of the note are indicative of either bad tubes, broken solder joints. It could be some leakage on the circuit board that's causing some DC voltage to reach the grids on the preamp and alter the bias of the preamp tubes. It's kind of where my money is right now. We'll check those out. I'll give you an update soon. Richard, I'm going to see if you're still alive. Whether that's ham? Is that ham or hand? It looks like Hanno, hand. I don't know, buddy. I'm going to track you down. All right. I'm going to lose power in a moment. But before I do, remember that distortion I was telling you about? Turns out it was due to an unbalanced phase inverter because the plate supply was not reaching it. Check this out. That should be a 100K resistor. Okay. It should be. But it's not. It's actually going to infinity and beyond. I'll show you this. It's an open. So I'm getting a lot of trouble here. So this is my meter's closed, shorted. I'm going to go back across that resistor. This metal film resistor has failed as an open. That's not something you see often, but these cheap Chinese resistors, something you're going to get. I went through and reflowed and touched up a lot of these old solder joints so they look nice. They're not going to cause you issues in the future. This would have been something that would have gotten you around the bend. But that's not where we are now. Let's get you a nice high quality 100K resistor for this position. And I'm kind of partial to carbon comp resistors for these particular positions here. So I am partial to them, even though that this dude went through and basically replaced all of them wholesale, just throughout the entire thing, with a few exceptions. That's what he did. That's what he did. And we want want to see, I'm just going to tack this in. Just going to tack this in here really quick. And we're going to see if this guy is going to give us what we need. And what do we need? Well, we need him to work. That's what we need. But this guy's dead. Okay. He's dead. So I'm just going to tack him in here. I'll straighten him up after. And I want a quick test just to make sure we can get plate voltage restored to this node here. And I believe we can. But why doesn't it hurt? Because I have no sense left, no sensation left in my finger from years of guitar. Not that I'm playing much these days. Let's get the volume kick back on, rather the power. Let's get her back here. And let's see. Before my phone dies, get her back over to DC volts. Let me restore this ground. Well, already much louder. And let's see. There we go. Bingo. Ezra, what's up, buddy? Just finishing up your cab here. So these do not work for the cables on hand, so I'll remove them and you'll get them back in your spare parts baggie. I did install some proper ones. Threw in some cable wraps for your stuff there. And inspecting your cab, I did notice that one of the bolts holding the baffle end will not tighten up. Unfortunately, this is something that I really don't do. But you will need a threaded insert mounted on the opposite side. So just something to keep in mind. And that's about it, man. So I'll get her wrapped up in one final play test, and then I'll get back to you. Bye. All right, Ezra, before I get this final sound test going, I swapped the two panels. Just makes more sense to have the lower panel flush with the bottom, and just this guy will just be what he's gonna be. Ezra, I don't know how this is gonna come across, but you've no more background hum. Just a very little bit amount in the reverb circuit. And again, the amp is backed up to some incredibly noisy stuff. So let's do my favorite settings, and you got yours. But right now it's mine. All right. It's probably so loud. That's so loud. That is so loud. Again, the baffle on this side, down here, up here, it needs one of those. It needs one of those threaded inserts with the claws that enter in. Unfortunately, perhaps that enter in on the opposite side of on the front side of the baffle. I believe. I'm no speaker guy though, so I'm no cabinet guy, so that's not really it's not my forte. Wow, these speakers sound great. They're so loud. See if I can. It's gonna clip, right? Single coil. Wow, that's the sound. I misspoke on one of the earlier segments where I should have said silver face. I was just caught up in the moment and emotional, obviously emotional. The silver face reverb amps, that's where it's at. A lot of guys have been have become prey to the internet lore that it's all about the blackface because these guys artificially inflated the prices of these things on the market. But what you're really hearing, yeah, build quality aside, yeah, I get that. But what you're really hearing on all your favorite recordings, the majority of that are the Silverface amps. Especially, let's get out of the blues arena and into the 80s. A lot of the like super sparkly clean, not the Rockman stuff, the super sparkly clean stuff in the 80s, you're looking at the Silverface Reverb amps. And they just do the thing like nobody else's business. This thing has had its bias circuit converted to blackface specs, but that's it. Yeah, the phase inverter, all that stuff is all Silverface. It's beautiful. That's a lot of reverb, drive, and dwell there. That's on 4. Good lord, and the bass response is unbelievable. So yeah, generally speaking in generalities, with this particular amp, you could actually run 6v6s if you wanted because the output transformer is actually 6.6K on the primary side. And you could actually run 6v6s or 6L6s with a primary impedance of 6.6K. So this amp has a lot more touch sensitivity, compression, all the good juicy artifacts that a cranked super reverb would have, but at a lower, more reasonable volume. So at 4, actually at 3 or 4, it's not that it's driving, it's that you're getting a little bit of probably core saturation from what is ostensibly or what is most likely 20-something watt output transformer. So you're going to get some saturation there from the output transformer, and people never think about that when they're designing amps. You could do all the dumble tricks you like, but there's nothing like an output transformer that's being saturated. Get the bass down a little more. It's always good to have a little too much of something that you can dial out. Oh, we're out of tune. Right? Let's take her down to 2.5 for the reverb. Level control there. Let's see what she does. Reverb on 10, ridiculous. She wants the feedback. Like it. Again. So, beautiful amp you got there, Ezra. Certainly unique. And I wouldn't change a thing about it. I'm serious. I just wouldn't change a thing about it. So, again, bare minimal amount of tube changes here for the service. I think we got it down to 3 just absolutely critical preamp tube changes, and obviously for the power amp, that new pair of 6L6s. Right now, your existing rectifier tube is hanging in there. So you're in business. You do have some other tubes that are, I'm not going to say marginal, because that's not fair. You do have some other tubes that are worn a bit, but they're still serving the purpose and doing the job. So I would just leave them in there until they become an issue or a nuisance, and then, season to taste. So, hey, it was a pleasure working on your project. Super interesting. Bye.